Today I'm going to be talking about the product and quotient rules for differentiation. So here are the notations for the product rule and then the quotient rule. We had it easy when we were dealing with the derivatives of functions that were added or subtracted from other functions, but multiplication and division of functions isn't quite so easy with derivatives. While it would make intuitive sense to just take the derivative of each piece separately and then multiply or divide the derivatives, that's not how this math works. We have to follow these specific rules. So if we have two functions that are multiplied together, to get the derivative, we must find the derivatives of each of the functions, and then do the first function multiplied by the derivative of the second function, plus the second function multiplied by the derivative of the first function. Similarly, if we have one function divided by another, to get the derivative, we again find each of the individual derivatives of the numerator and denominator, and then put it together like the rule says. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Now, while these rules look complicated, you don't usually need to memorize them because more than likely your teacher will let you use a formula sheet with these notations or similar notations. However, most students get comfortable enough with the rules that they somewhat unintentionally memorize them. However, note that the orders can get confusing, so unless you're really certain of the rules, it's a good idea to double check the order of the components prior to actually calculating the derivative. Another thing to note here is that both of these rules have the same four parts, the two original pieces and the derivatives of those original pieces. And that makes it really easy to solve these types of problems by finding each of the four pieces individually and then putting them back together like a puzzle. So let's look at an example of this. Here we have an example of the product rule. The rule and the different components are shown at the top. The function we have been tasked with is the 2x squared plus 4x times 3x minus 1. We then identify the different pieces, f of x being 2x squared plus 4x, and g of x being 3x minus 1, and then take the derivatives of those pieces in the lower left. Finally, we put all of the pieces back together as the rule dictates, and then simplify. If you need to take a closer look, pause here for a moment, or try to follow along on your own. I'll also have some practice problems for you to work through on your own later. Now let's take a look at an example of the quotient rule. Just like the product rule, we're going to identify the different pieces of our function. So f of x is 3x squared minus 2x, and g of x is 4x minus 5. We find the derivatives of each of those pieces and then put all four pieces back together as the quotient rule says. A few notes about the quotient rule though. First, there is no need to multiply out the denominator because it likely won't cancel with anything in the numerator. Or on the rare occasion that it does, it will be easier to spot that it cancels with a similar factor rather than the multiplied out version. So, in short, don't mess with the denominator. Second, the numerator will likely need to be cleaned up a bit, but there's really no reason to keep rewriting the denominator since it doesn't change. So I often just simplify the numerator on its own and then put the denominator in at the end. If you have trouble remembering to put the denominator back in, you can absolutely keep rewriting it. Or you can put a placeholder like I did here with the green DEM, short for denominator. Third, unlike the product rule, which had addition, the quotient rule has subtraction in the numerator. And this is where I see a lot of students make mistakes because they won't flip the signs to the right of the negative. It's a good idea to multiply out the right side on its own and keep it within parentheses, and then flip all the signs at once when you pull it out of the parentheses, which is how I did it here. First, I multiplied the 3x squared minus 2x and the 4, still keeping it within the parentheses. Then when I brought it out of the parentheses so I could combine it with the other elements in the numerator, I switched all the signs on each of the elements within the parentheses because each element is essentially multiplied by a -1 when I take it out. This is definitely a part I see many students mess up on, even though it's an easy fix. So just be cautious when simplifying the right side. And that's all you need to know about the quotient rule. So let's take a look at some practice problems. Here are the practice problems for you to try on your own using the methods that we just discussed. With the first two, you will need to use the product rule, and with the second two, you'll need to use the quotient rule. I'll reveal the answers in just a moment, but you can pause the video here while you work out the solutions on your own. Here are the solutions to the practice problems. Take a moment to check your answers and perhaps go back through the steps carefully for any that you missed. One last thing I want to talk about is when you actually need to use the product or quotient rules. The answer is you only need to use these rules when there are two functions of x multiplied or divided. If you look at the examples below, the ones on the left where you would need to use the product or quotient rules have an x in both parts, while the ones on the right only have an x in one of the two pieces. To be clear, using the product or quotient rules will still work in these cases on the right because you are still multiplying and dividing, but it will make the math much more complicated than it really needs to be, and you're far more likely to make a mistake in the process. Life and math will be much easier if you can recognize when you need to use these rules and when other rules will be much quicker and more helpful. If you want to test this theory out, try to solve a couple of the ones on the right using the product or quotient rule as it applies, and then solve it again using the rule or rules I suggest on the right. I hope this video helped you understand how to use the product and quotient rules to solve derivative problems using multiple functions of x. Thanks for watching.